we're going to get some amazing insights collected from 3 speakers tonight. Helena Yu is an AI expert building AI and ML solutions in the tech, finance, insurance, retail, telecom, and nonprofit sector. Luis is an analytics professor and consultant in Gen AI, specializing in RAG, Retrieval-Augmented Generation systems, and multilingual chatbots. And Maryam is a senior data scientist in the areas of ML, machine learning, and artificial intelligence with a PhD in physics. And with that, I'll ask, oops, no, I will not ask that. Sorry, I skipped one ahead. With that, I would love to have the speakers present, and I guess Helen will be going first. Yeah. Great. Not a problem, not a problem. We'll make it work. We'll make it work. Gabe, do you just have a sec here for the slides?
Yeah, sure. There, the next presentation. Do you need presenter slides?
No.
Okay, great.
Okay, I'm just going to hold this. Yeah, okay, awesome. Yeah, so hi, my name's Helena. I'm here on behalf of a nonprofit that Kate and I run called Climate Resilient Communities. And today we'll be talking about one of our projects is Multilingual Climate Chatbot. Okay. Okay, so what do we do as CRC? So our mission is really to help Toronto communities, especially the marginalized and youth, to become more resilient to climate change. We believe in co-creating solutions with the communities, addressing their climate anxieties, improving their climate and data knowledge and skills, so that we can increase their participation in climate adaptation. So we have a couple of initiatives here. I'm just going to quickly run through, and also just while we wait Louis to arrive. So we run a youth data literacy and climate program. We just ran a couple of co-creation sessions with youth in Rexdale and Black Creek, Jane and Finch area. Trying to help them to become more skilled in the data and climate and green skills in general, to hopefully help them to become more employable in the future, because we believe that every job is a climate job down the line. And we also have a climate adaptation policy program that focusing on using data for policy advocacy around climate change. And we'll talk about the multilingual climate chatbot more in depth, but the third project is in collaboration with Kids Cell Phone. So what we do is that we take basically open source data set like Reddit, Twitter, and filter down to climate specific as well as youth specific posts, and understand what are the signals of climate anxiety among youth, like and then for different climate emotions, what are the topics associated with it, basically to help KHPs to better design intervention mechanisms and support mechanisms for youth who are calling in. And we also recently conducted a climate resilience data gap assessment with help from Statistics Without Borders. We're also working on a climate stories map that collaboratively record climate change experiences and climate emotions across Canada to help end climate silence. Basically, is that people don't feel comfortable sharing about their climate emotions and talking about climate change with other people. So now is sort of like, what we talk about in terms of a multilingual climate chatbot. So the goal is really to help make localized climate informations more accessible to Toronto's diverse and marginalized communities. As we all know, like most people, like there's like top 10 languages that commonly spoken in Toronto. However, most of the climate change information and literatures are only in English and French. And when we're thinking about where the climate injustice are, is that the marginalized communities are burdened with the most cost of climate change, but they also have lesser resources to adapt, including information about how to adapt, how to mitigate and prepare for those climate risks. So what we know is that there's a lot of climate knowledge reports, strategy, action plans out there. They're oftentimes in different repositories, and they're often filled with jargons and English and sometimes French. And in terms of like marginalized communities, they have understanding of climate change from the communities that they originally came from, but they don't understand how climate change affects them in the global north. And they also have very low capacity to engage sometimes in climate change because they're struggling with issues like food insecurity, housing, poor housing conditions, poor transportations, heat stress, flooding. And then we also have seen high rates of climate anxiety among them, and they're oftentimes excluded from decision-making processes. So what we're trying to do is to not just necessarily make this publicly available, but really engage with the communities to help them make these information more accessible and easy to understand for them, integrate it into communities' workshops and communities' channels. And hopefully that will increase their capacity for data-informed climate actions, reducing their climate anxiety, and then enhance their personal and collective resilience overall. So this is just some stats just to help you better understand what problem we are solving right here. One is understanding and engagement with climate change in Toronto. A lot of Torontonians lack basic understanding of climate change. A lot of them are unsure of what actions they can take. And a lot of them, like 30%, believe that there's nothing they can do to make a difference in climate change. So it's a very bleak view of the engagement in climate actions in Toronto. And also based on the climate resilience strategy and the perception survey, there's low engagement with climate adaptation resources and information. There's limited capacity for people to take proactive measures against climate risk. And we see very high rates of negative climate emotions among youth. And again, youth and marginalized communities are often excluded from the decision-making processes, further exacerbating existing inequalities in Toronto. So we started working on this actually from April-ish. And then we went through, so Cohere did an IR expedition because they're the best in terms of coming to like multilingual capabilities around the realm of large language models. And we started doing a hackathon with them, and then we won the top prize for that hackathon, thanks to Louis for leading that. And then in the past 3 months, we have been focusing on refining our RAG solutions, making more robust guardrails, so making sure that people are not using this to do their essays or math homeworks or any other, making a chemical bomb, things like that. And then try to make the inference speed faster and make sure that the embedding models are fine-tuned so that we can improve the retrieval accuracy. So we are aiming to launch this in January and February next year. We're wrapping up with the go-to-market strategy, and that's developed by EVI. And hopefully we can start integrating these solutions to community work from March to August. And then hopefully down the line, we can incorporate not just qualitative information based on reports and research, but also spatial temporal data for better decision-making in the communities as well. So who we help, we sort of touch on this. So individuals, communities, and community-led based organization. So for the team, Kay here is sort of like leading CRC, and then we have Louis, who's been basically spearheading this, pushing this through since April and May. And then we also have Maryam on the line. She recently moved to Boston. We have like basically an all-star team, and then the broader, we partner with different organizations for all of our different initiatives, and we have about 30-ish active volunteers with us. So without further ado, I will pass this to Maryam to talk about the technical architecture of our chatbot.
Thank you, Helena. Do you hear me?
We can hear you in the room.
We can hear you
Okay.
online, a little bit echoey, but we can hear you.
Okay. Hello, everyone, and welcome to our chatbot. Let me walk you through how it works. Let's ask the question. The chatbot runs it through 2 quick checks. Is it safe and appropriate? Use prompt guard from MetaLlama to make sure the question is non-toxic and respectful. We also check its relevance to climate change topics using the climate bird model. If the question doesn't pass these checks, the chatbot won't answer. But if it's good to go, we move forward. We first check our cache to see if the question has been asked before. If it has, we give you the cached answer right away. If the question is new, we make sure to remove any personal information to protect user privacy. Next, the question goes into our RAG system, that's short for Retrieval-Augmented Generation. This system searches our database for relevant documents to build context for the response. With this context, we generate the response using Cohere Command Atlas language model. We also provide references that we have used to generate response for anyone interested to learn more in depth. We are not done yet. The final step is to check if the response is factually correct and it's based on our document and it does address the question. If the response passes all those checks, we give the answer to the user. If not, we regenerate the response performing a web search to find relevant information. Can you go to the next slide? Okay, now let me talk about our RAG system, how it generates context for our response. We have curated a collection of research papers and reports about climate risks and adaptation and converted them into Markdown format and divided them into smaller structured text. Then we generate dense and sparse embeddings from our documents. We use BGE entry model to do that. Dense embeddings capture the semantic meaning of text, and the sparse embeddings focus on keywords. We also fine-tune dense embeddings to align our embeddings with our vocabulary and context to enhance our retrieval. Although our documents are all in English, our embeddings is multilingual. So it means that similar topics are mapped closely in our embedding space. When a query is made, it's embedded in the same way, and then we search in our Pinpoint database to find the relevant documents to our query. We perform a hybrid search combining keyword and semantic similarities to find the relevant documents to our query. And then the retrieved documents are re-ranking using re-rank multilingual model from Cohere and to make sure that the most relevant document comes first. Can you go to the next slide? Now let me talk about language diversity. Actually, a Command R+ language model supports 23 languages, including English, Spanish, Italian, French, Chinese, Persian. But Toronto is a multicultural city, and many users may speak languages outside these 23 languages. What we do? To address this, we use AI language model, which supports more than 100 languages. If the query is in language, the query language is supported by Command R+, we use our existing system. But if not, we use AI model to translate it to English and we generate response. And at the final step, we translate back our response to the original language and give that to the user. And that's it. I pass to Helena.
Hello? Is it? What's Maryam's share screen? Is this working? Hello?
Just for the online folks.
Okay, awesome. So welcome everyone. I hope you give a hand applause for Helena and Maryam. They did an awesome job helping us out. So Hacknight. So we just saw through a couple of slides of why we're doing this and what's the purpose of this, right? So what's really interesting and what's really great about this project is that Maryam explained, we're doing things that most typical RAGs don't do, and we're getting deeper into the details. Maryam just showed us showing where we fine-tune our own embeddings for this model. So how is that different from ChatGPT? How is that different from Gemini? If someone were to go to chatgpt.com and ask a question about climate change, how would that better the responses about doing these different things? So first of all, we have a repository of fine-crafted PDFs all about climate change in the Toronto area. So that's our main scale. And we have that already defined, pre-structured, and we have it refined that way. Then we grab from these chunks, we do QA pairs. From these QA pairs, we train an embedding model based off these QA pairs. So the auto retrieval can get a little bit more there, right? So what you could take from tonight in terms of a Hacknight, in terms of what you can really understand is how can you really improve a RAG? How can you really get better retrieval? One of them is fine-tuning your own embeddings. You don't need a high GPU for this. We used Google Colab, grabbing those embeddings. We used the embedding model that's open source, and we're able to use that to train our model to really get the best retrieval, right? The second part of this, the RAG that Maryam was talking about, is the multilingualism. So we tried different ways of doing this. We tried just using normal embeddings, but we weren't getting the right retrieval, right? So we want to make sure that if someone's asking a question in a different language, can we go into our PDFs that are all in English, retrieve the right chunks from there, and bring it back? So how do we do this? We do this through multilingual embeddings. So using Cohere, and Cohere has been a great support for us, great sponsors in terms of open source. Using their multilingual embedding models that they have, you're able to then embed your QA pairs from your PDFs into what we have today, right? So that was a huge push, and you'll see today in sort of our live demo of how we're able to make this happen. So let's go straight to it, and we know the best way to show a POC is through Streamlit or some sort of front-end app. So let's get to it. So Maryam, are you able to share your screen and open up the POC? I think it's click
Turn the screen share off so that
Yeah.
I need to try. Let's see. Stop this. Great.
Perfect. All right. Thanks, Maryam. Okay, so what's with our chatbot again? So again, we're trying to do something fast to market, and again, because this is something that's we're a non-for-profit organization, we're actually getting a lot of support from EY to help push this forward, because we're identifying a need, right? A lot of people and a lot of communities don't have access to read documents not other than just English. So how can we get something that's accessible, a tool for them, right? We're not doing something we're not inventing a rocket ship to go to space. We're inventing a tool that is necessary for these individuals to learn more and what they can do. So how can we do this? We're using AIA model. AIA model, as Helena talked about, is 101 languages. So it's 101 languages from the LLM. That's more than ChatGPT. That's more than Gemini right now. It's a large language model that's open source that has been trained from people all over the world. Using this large language model, we can then decide on the left side, please select the language that you'd like to speak, right? So in terms of this purpose, we're going to use English just first. Once they confirm the language that they're speaking about, they go straight to the bot, just like a typical experience, and you go in there, right? So Maryam's going to help type a question in English of how this is going to work, right? So what is climate change and why should we care? A simple question in English that we can simply answer. Then it's going to go through our retrieval model and respond. So our retrieval model is based off prompt engineering. We're prompt engineering that this should be as a tone of a grade 9. So again, for people who are going into ChatGPT, going to Gemini, who are young, who don't really know much about climate change or the words or terminologies, we are taking away the part where they have to say, well, talk to me like I'm in grade 9, remove jargon. They can go into this space and just ask questions that are simple and easy to read. Now, what happens after next? We have our planet's health, impact. It gives 4 bullet points of why it's really important. But what's really important for us is how is this true and what's the sources? So we make sure we've had every single chunk, every single URL that it's pulling from our large curated repository of documents, that they can see the title of where it's coming from. They can click on the URL, read the link themselves, and what is the cited source. So again, these individuals can then get the information, read more about it, and understand why is it so important for them, and get deeper knowledge, and really giving them the tools in their hands to get them started and get to learn more. What's really great about the front app too is on the left side, we have a chat history. So let's say you're having a great conversation and you really know what's going on. Again, I decided to put in there an option to download. So after you had the great question, you really don't know what's going on, you can then click on the download button, then download this, and then you can use this, for example, if you're writing a paper or if you want to print this off quickly. We know a lot of people like that. What the famous business question is like, can this be exported to Excel, right? We're removing that option and putting it, can we export this into a text file that we can just print off easily and have it as a reception? So here we're just giving all the different tools and options to these users so they can understand this. All right, let's do one more question. We'll do another question in another language and see how well the model responds. All right, we're going to do Spanish. So I can verify this is going to be right or wrong. We're all messed up. So let's see. Maryam's going to write a question. What is climate change? Simple in Spanish. So because we're using multilingual embeddings, it's able to understand that we're able to then grab that language, look at the documents, pull out those chunks, and then respond based off those chunks. So again, as you can see here, the model does respond in the other language that someone put Spanish. It is responding now in Spanish and grabbing the same facts that would have for them. They would have to go to Google Translate, select the documents, translate them for themselves to really understand more. The really point of this and the feasibility of this is to give something a quick, easy access information to individuals who are having a hard time finding it. They can have information that's quick and able to print off on the left side if necessary. All right, let's do a harder language that we know that it's not simple, right? So maybe we can try Persian this time, Maryam. Let's see if it's able to read Persian and be able to translate Persian this time. As you can see, it's not as easy, fun to type, but it's able to grab there. So again, the purpose of this multilingual chatbot is, can you choose a language that you want to respond in? Is it able to respond accurately, appropriately, and is able to provide the right text, right? And we want to create a safe space. And the whole point of the climate chatbot is that safe space. We know the answers have been chosen from our talented team, like we have here, that have chosen these PDFs from the cities, have chosen these PDFs, looked at the documents, and ensured that they're all based in Toronto areas. We're going to be improving this, expanding this more as we continue on. You can look up certain documents like from Rexdale communities, from Black Creek. We can look up different documents specifically in Toronto communities. And if you have questions about what can I do to lower my heating cost, or what can I do to help that way, and you're not really that comfortable in English, this is the safe place to come in. They can simply just go into the app, ask a question, and then have it respond in the language that they almost feel most comfortable about, right? And the whole point of this is, in Toronto, we know that multilingualism is the main concern here. Majority of us come to Canada not knowing English, right? So how can we help those get in those hands in that way, right? So again, we want to thank you for your time. This is what we want to show in terms of presentation, what we've been working hard on, and I'll pass it off to Helena to continue. Okay.
You switch back to the other slides?
Yeah.
Okay.
Just
Okay, great.
is it the right slide?
It's all black.
Okay.
Let's change the screen.
And if it's in full screen, that might be the problem. Great.
Just to add on what Louis said, right? So we build everything based on the models that are open sourced, including the embedding model, including all the IA model, Common R+. They are all open source. What that means is that what we build here is reproducible, reusable. Any city, like communities, can take our code, feed in the PDF, and run their own instance of the multilingual chatbot. We strongly encourage everyone to sign up for our beta testing. So as we talked about earlier, our launch will be early next year. But before that, we'll really rely on our beta tester to figure out what's wrong with the chatbot in terms of like the technical bugs, but also the reliability and accuracy of the response, depending on if you're a tech person or a climate person. And we support, many languages. It's also important if you speak more than one language, we would love to have you to provide that feedback to us, whether that information is actually relatable, making sense in your language. One of the issue that we know with the chatbot is like the French is not Canadian French, and there's not that many models support that. So like that's one thing that we've found out. But just, those are small things that really need your help to be able to figure out and further refine this before we push this further to all the communities that's out there in Toronto. And then we also have different socials. We have LinkedIn, Instagram, Linktree. And then if you're interested in volunteering with us, we, as I mentioned in the previous presentation, that we run a lot of different programs and projects. So if you're interested, feel free to drop us an email and we'll connect from there. Thanks, everyone.